Hello, and welcome to today's HIMSS and Government Health IT webinar, Unified Approach for Sharing All Images and Records to Streamline Continuity of Care and Achieve Meaningful Use, sponsored by eHeathTech. Image and record sharing is often cumbersome and expensive, and still does not reach all caregivers, despite large investments in EMR, PACS, VNA, and HIE. During this webinar, you'll learn how a new and unique single solution can get images and records to all caregivers as part of the patient record, while connecting referring physicians with their patient's progress. Our first speaker today will be Michael J. Gray, Principal at Gray Consulting. Michael's areas of expertise are market analysis, technology analysis, strategic planning, needs assessment, workflow analysis and redesign, business case modeling, vendor analysis and selection, and technical contract negotiation. Michael routinely publishes articles on his blog, www.graycons.com, on subjects related to departmental PACS and the latest market concepts, including vendor-neutral archiving and image-enabling the EMR. After his presentation, Michael will be joined by Ken Rosenfeld, President and CTO at eHeathTech. Now I'd like to hand it off to Michael to begin our presentation.
Thanks, Mike, for the introduction. Welcome, everyone. Today we're going to look at a unified approach to sharing images and records. I want to share with you today a great concern of mine regarding the disconnectedness of continuity of care, how limited sharing of information happens today, and what solutions are out there to make this process much more streamlined and unified. I'm going to suggest a combined solution of technology and skilled services that I think is affordable and I know is deliverable today. It's a solution that shares all images and records for all caregivers. Who doesn't believe that our healthcare system is still broken when it comes to efficient transitions of care? Well, the Institutes of Medicine certainly believe so, and they published these statistics in September of last year. 20% of patients reported that their medical records and images did not get to the provider with whom they had an appointment. 25% of patients say their physicians reordered tests to have accurate information for a diagnosis. Well, certainly, this adds cost to the system. And furthermore, it's both inconvenient for patients to have new lab work done, and the unnecessary radiation exposure, like from an additional CT, well, that's just bad patient care. There have been many advances in electronic medical record systems that improve care within a facility. But for transitions of care, records are still missing, and a unified view is seldom achieved. Like the bubbles of mercury depicted on this slide, the many systems do not naturally merge patient information. The problems are diverse, just like the many systems involved. Faxes that end up in the wrong folder or don't make it into the EMR, image CDs that don't work on the receiving end, unresponsive outside image providers not delivering the images on time, patients that are confused and don't comply with record and image collection requirements. Meaningful use initiatives support the drive to share better. Over the last 3 years, there have been a burst in EMR deployments at hospitals and clinics, and physicians prepare themselves to meet the meaningful use requirements mandated by the government. At present, through stage 2, most of the requirements address electronic charting and using EMRs to manage and access clinical information. This management of result reports, care summaries, and outcomes is based on what we refer to as little data that's ingested and managed by the EMR. EMR solutions do not manage big data like medical images. Furthermore, many EMR solutions do not include even a basic medical image viewer. Now, as we progress to stage 3, access to comprehensive patient data will be a requirement, and that will certainly include medical images. Most organizations addressing image and record sharing probably found it necessary to deploy several completely separate solutions, along with expensive interfaces and integrations. So EMRs were just not designed for external record sharing and for managing images. When it comes to sharing images and records with outside caregivers for continuity of care, the current systems are just broken. Let's take a look at the conventional solutions to image and record sharing, along with their associated problems. And after that, I'll present what I consider to be an ideal unified solution to image and record sharing. We need to find ways to improve sharing of healthcare records and images in a unified manner. There are countless use cases that require sharing of images and records. For this presentation, let's focus on one of the most complex use cases. Patients referred to a cancer center for further diagnosis and treatment. The cancer center is part of a health system, and it shares the health system's EMR. Many types of images and records are needed from multiple providers, both inside and outside the health system. I want to speak about three types of sharing. First, getting images and records before referred care or treatment. Second, internal sharing, within the health system during referred care or treatment. Third, external sharing after referred care or treatment. So let's take a look at conventional approaches to getting the records and images from outside providers. This process usually begins with the referral itself. Without guidance, it's difficult for referring physicians to know what specific information, records and images are needed. They may send too little or way too much. And it's often sent in a disorganized manner, usually by means of faxes or mailed copies. It's not just an order for a procedure and a delivery of a result. It's a transfer of care from one provider to another. All relevant records and prior imaging studies are needed for good patient care and continuity of care. The records and images come from multiple sources, and nothing is unified. Faxes don't get into a patient's physical or virtual folder. Pathology slides are sent to the wrong place. Often there's too much information, and the physicians are left to wondering, how in the world am I going to go through all of this? How to go sort through all these reports and images? The electronic data management systems, they could certainly help with the organization, but EMRs don't talk to each other. Neither do PACS. One approach to getting the right records and images is to ask the patient to get them. And so the patient is burdened with getting the required information, an anxious and often sick patient. And the staff at the patient's providers are burdened with ad hoc and sometimes confusing requests from the patient. This approach tends to net all the records and images available, not just the ones needed. And the patient may not be able to get everything required. Most importantly, this approach takes a lot of time. Another approach is to use internal staff at the treatment facility. The staff requests specific records and prior images from all the patient's caregivers, usually by phone or fax. Responses are often delayed or sometimes even ignored. Now, the staff is burdened with other responsibilities, and they may find it difficult to keep up with and manage the process effectively. Records are often sent by mail or fax, and images copied to film or CD. In both cases, the treating physician is faced with a disparate collection of records and prior images, and they may not even be complete. What about health information exchanges? Well, HIEs can certainly handle some of the records, such as results reports, discharge summaries, and others, but all the records are not uniformly supported by HIEs. And this approach works only if the provider is collected to the exchange. And let's not overlook the fact that most HIEs do not handle images. The conventional solution to getting images from outside providers is to copy the images to a CD. The CD is burned on site and then sent with the patient or mailed. The response time, well, it is what it is. The numerous problems associated with this solution are well known. It's very time-consuming. the request for the images may or may not be immediately addressed. The process of locating the images in the packs and creating the CD copy is labor-intensive. Relying on the patient to be the courier places an unfair burden on someone who has other things to think about. Of course, there are numerous examples of the media being unreadable or the image data itself being somehow incompatible with the receiving device. Another approach for getting images is through subscription to a cloud-based solution. But will the provider of the images deliver the images promptly? How do you reconcile many additional viewing platforms for each provider's cloud-based system? Who ensures that relevant and correct images are delivered? Can the recipients remember their password? How do you get the associated reports? Can the recipient forward the images and reports to their EMR? Is adding yet another limited technology solution really the answer? The treating physician cannot be assured of timely record delivery, so they often wait to receive all the records before they'll set up the first appointment. The end result of this inefficiency is delayed treatment, often 2 to 3 weeks after the referral. This results in unnecessary anxiety for the patient, in addition to the delayed care. The ideal solution to getting the records would achieve these goals. First, all records and images would be transferred electronically. Second, delivery would promptly follow the request. Third, all records would be organized and forwarded to the requesting organization's EMR, and the images would be forwarded to the appropriate packs. Fourth, there would be an efficient manual process to handle records that are not in electronic format. And last, the ideal solution would assure prompt delivery. I've been addressing some of the issues with getting records and images. Now let's look at sharing records and images inside the health system. Most records are handled well by the health system's EMR. So I want to focus first on the issues with images, or more specifically, how to image enable the EMR. So what is meant by image enabling the EMR? All caregivers depend on access to the various department packs because that's where the image data is stored. And each of those individual packs provides its specific clinical viewing application. In this first scenario, each of the EMR systems are interfaced to each of the department packs. The nature of that PACS EMR interface is such that the EMR is aware of which PACS is managing a specific patient study. Now, this simplifies the user access to a specific patient study because any of the EMR systems can find any of the patient studies. Once the user is logged into the EMR, it's usually not necessary to log into each of the packs in order to access the images. Working within a specific patient context, the user is informed by the EMR of the availability of images associated with the results report. Accessing those images is then as simple as clicking on a button. While finding a specific image set is greatly simplified, it's important to emphasize that each EMR still requires an interface to each department PACS, and the user must still learn how to use each of the different PACS clinical viewers. This scenario is the conventional approach that most healthcare organizations have taken to image enabling their EMR, the interfacing each of the EMR to each of the PACS. While this approach simplifies the task of finding the desired image and study, there are a number of significant issues or problems with this approach. First of all, a separate EMR PACS interface has to be developed and maintained for each EMR and for each department PACS. Many organizations are behind in the deployment of all of these interfaces, so the complete longitudinal record of the patient's medical images is incomplete. Some organizations have chosen to solve the multiple interface problem by funneling non-radiology images to the radiology PACS. Well, this simply creates another set of problems. This strategy limits the user to the features and functions of the radiology viewing application, which are generally not very applicable to other imaging modalities, for example, cardiology. This strategy actually costs more than the cost of the separate EMR PACS interface, as it duplicates the storage capacity required to manage the images in two PACS, and it duplicates the cost of the software licenses associated with the acquisition and management of the image data in two separate PACS. There are also problems related to the nature of that EMR PACS interface. In many of the older EMR PACS interfaces, the EMR link to the images in the PACS is hardwired. It's not dynamically created on the fly. So when the PACS is replaced, those links don't work with the new PACS. Because this approach involves accessing and using the individual PACS clinical viewers, the users have to learn and use multiple viewers. And because the patient's complete longitudinal record of medical images is scattered all over multiple PACS, it's impossible to view all of the patient's images in a single viewing session. Most PACS clinical viewers are only compatible with Windows platforms, so the user cannot access the images on their Mac or their tablet or their smartphone. Most PACS clinical viewers are web-delivered thin client applications that reside on the viewing platform. This requires the eventual delivery of large volumes of pixel data to the viewing platform, meaning performance routinely suffers over low bandwidth connections. Alternatively, the clinical viewer could access a lossy version of the images, but a lossy version frequently doesn't satisfy the user. An alternative to image enabling the EMR through multiple PACS interfaces and multiple PACS viewers is the deployment of a combination vendor-neutral archive and associated universal viewer. Now, this approach consolidates all of the enterprise image data from multiple department PACS in a single repository and reduces the interface count to one per EMR. And each EMR is then interfaced to a single universal viewer, which accesses all the patient's images from that single VNA. This approach means that the users only have to learn and use a single viewing application. And it also means that all the patient's images can be viewed in a single viewing session. Unfortunately, deploying a vendor-neutral archive is a major IT project and requires substantial planning, lots of calendar time, substantial IT resources to both deploy and support the system, and significant financial investment. Deploying a VNA and associated universal viewer to image enable the EMR it's like taking a sledgehammer to drive a tack. Looking beyond the issues with images, the referring physician needs to know what's happening to their patient at the referral facility. Did the patient show up? What is the treatment plan? What follow-up is needed? All too often, the referring physician doesn't hear anything until after the treatment is complete. Here are the goals for the ideal solution to internal image sharing and communication. Image enable all of the EMR systems with a single viewing application that connects to all of the PACS or to a VNA that manages all of the images. Organize the records that are placed in the EMR. Forward all of the images to the appropriate PACS. Establish a timely communication channel with the referring physician. Provide all caregivers the means to access all records and images. Now I'd like to speak about sharing images and records from the health system to outside providers. EMRs are handicapped when it comes to communicating with outside physicians. Templates for printing a letter to mail or to fax, that just doesn't cut it anymore. Sometimes access is provided through EMR portals, but managing security with outside providers is a challenge, and EMR portals often do not provide access to images, at least not to all the images. In this competitive environment, communicating to referring physicians is critical to a health system's welfare. Referring physicians need access to images and results to continue treating their patients. PACS are also handicapped when it comes to sharing images with outside physicians or with other PACS. PACS tend to be isolated to within the health system. Some PACS are even isolated to within the department. Integration of department PACS with outside systems is difficult and rare. And lack of this integration prevents the construct of the complete patient record. What about sharing images and records with outside physicians through a health information exchange? Well, as I've said, HIEs only handle the little data. They handle only some of the records. Not all of the outside physicians may be connected to the HIE. Here are the goals for the ideal solution to external image sharing. The ideal solution is to image enable the HIEs, image enable the EMR portals, provide access to all of the department PACS images, provide access to all of the EMR records, and finally, to provide access to the patient status, which effectively means providing a timely communication of the patient's status to the referring physician. The goal is to get all images and records to all caregivers by achieving a unified approach to manage the process of getting all pertinent records and relevant prior images, and developing a single solution that supports both internal and external sharing of all those records and images. We need a unified methodology for handling the big data along with the little data. That is to say, all of the patient's data, and thereby ensure that the entire referral care cycle is streamlined. Here's a complete list of what should be our goals. Electronic transfer from all sources in a timely manner. Organize the records and then get them into the EMR. Forward the images to the appropriate PACS. Enable efficient manual processes for records that are not electronic. Image enable the EMRs and image enable the HIEs. One way or another, connect all of the EMRs to all of the department PACS. Now, you already know that my recommendation is to connect to the PACS through a single universal viewer. Establish a methodology for timely communications with the referring physician. And enable all caregivers with access to the complete patient record, including images and EMR records. Now, I realize this is quite a challenge, but let me share with you an approach that I believe can meet all of these goals, an approach that, in fact, is a single, unified platform and set of services. First, let's take a look at a unified solution for images. The ideal solution for bidirectional external image sharing and internal image sharing would be a single unified solution based on the same technology components, simply packaged in different configurations to support different use cases. In this first of 4 high-level block diagrams, I present the technology components required to support bidirectional external image sharing through an HIE. Note the 4 key technology components in yellow. First, an external image exchange server in the cloud. Then 3 internal components packaged in a sharing gateway located in the organization's data center. These 3 consist of the DICOM router, which handles the tag mapping and the interface to the local PACS. The viewing server, which is the rendering server for the zero-client viewer. And the reverse proxy server, which processes user requests from the HIE and allows user access to the viewer. The gateway in this case uses a VPN connection to the cloud. Also note that there's an image cache associated with the rendering server, and it's presented here in orange. and the VPN connection is presented here in green. The HIE is image-enabled by a system that manages the image data in a cloud infrastructure, and here's how that would work. The HIE handles the credentialing and uses its internal EMPI to reconcile discrepancies between the MRNs of the sending and receiving parties. Edge devices are deployed in the facilities that expect to do a high volume of image data transactions. And a simple software application is deployed on a local PC to support facilities or parties that expect to do a lower volume of image data transactions. As soon as the HIE receives an imaging report, it sends a command message to this cloud-based image share application to forward a message to the edge device or the software application located at the facility that sent that report. That message results in the transfer of the associated images from the facility to the cloud. As soon as the arrival of the images in the cloud is confirmed, the HIE embeds a link in the report to its associated images that are now located in the cloud. The cloud infrastructure includes a diagnostic quality zero-client viewing application that utilizes server-side rendering technology. The receiving party uses the HIE application to access the patient's health record. In the example shown here on the slide, the Radiology tab displays a list of the radiology reports that have associated images available to access. So in the ideal solution, the user has the option of viewing the images using that zero-client viewer, or having the cloud infrastructure automatically download the images directly to the local PACS or to a workstation, etc. In order to guarantee that the image data being transferred from the originating PACS is fully compatible with the receiving PACS, the cloud infrastructure must include tag morphing functionality, like we talk about in VNA. Now, I want to point something out important here, that viewing images through the zero-client viewer does not involve downloading all of the pixels and all of the grayscale to the user display platform. The server-side rendering application, it's sitting right there in the cloud next to the uncompressed image data. The image result from the rendering operation that's actually downloaded to the PC or the Mac or the mobile device, that's actually a web page forwarded via HTTPS. In this second of 4 high-level block diagrams, I present the technology components required to support bidirectional external image sharing between users that do not belong to an HIE. And once again, the 4 key technology components are indicated in yellow. In this case, there's no need for a reverse proxy server, but I have added a CD upload utility. Both of these external sharing gateway components are simply software modules that can be hosted by a PC. In this case, the viewing server, the associated image cache, and the image exchange server, they're all located in the cloud. All of the external communications and data transfers are secure HTTPS, not VPN. The key technology components are virtually the same building blocks repackaged and relocated from on-site to the cloud. In this third of 4 high-level block diagrams, I present the technology components required to support internal image sharing, both through the EMR physician portal and directly, straight to the viewing server. This application only requires 2 of the 4 key technology components, indicated again in yellow, the DICOM router and the viewing server. The internal sharing gateway in this case uses a URL connection over the local area network to communicate with the viewing server. And the image that results from the rendering operation is delivered to the user via HTTPS. And note again that the image cache associated with the viewing server in this case is considerably larger because it's typically sized to manage 6 to 12 months of all new study data forwarded by the local PACS or imaging facilities, or imaging modalities, rather. Images are accessed and managed from the report just as they are in the HIE example. Click. In this fourth high-level block diagram, I present all the key technology components required to support all of the organization's image sharing applications. That includes bidirectional external image sharing between users that are both connected through an HIE and those that are completely independent. And internal image sharing, both through the EMR and directly through the universal viewer. The key components are the building blocks. They're the same. They're just packaged slightly differently in this unified configuration. Note that there's some component duplication. The image viewer is both on-site and in the cloud, and therefore this associated image cache is both on-site and in the cloud. Now, the point I want to emphasize here is that using the same key technologies as building blocks, it should be possible to configure a unified image sharing solution that will satisfy all of the organization's image sharing requirements. I also want to emphasize that the organization should be able to start with any one of the image sharing applications and then add any of the other applications by simply adding any missing key components or changing the packaging or upgrading the software licensing to match the requirements. Now I'd like to discuss a unified solution for records. A cloud-based referral management application is an ideal way to manage a patient referral. The referring physician logs into this referral management application and is guided to enter just the information specific to the patient's condition. The referral management application then provides a specific list of all the records that are needed. The referral management application is also used to provide up-to-date information on the patient's treatment and notifications of any important events. The referral management application, they can even give the treating physician current trends on referral activity, thus allowing them to deal immediately with any fall-offs in referral. Unfortunately, the record retrieval process involves many sources that need to be managed. When outside records are requested, you need all the following: management of patient consent, timely access to complete records, quality reviews for accuracy and legibility and completeness, protection from outside facilities sending the wrong patient's records, minimal staff time spent requesting and accessing and then delivering records and images into the EMR and PACS. Records delivered to the EMR chronologically and by record type. So all these tasks need to be unified with all other aspects of sharing infrastructure, such as access to outside images in the EMR. An ideal solution would be to use skilled professionals to manage patient consent when needed, collect all required records, and get them quickly and efficiently, and then organize them and then place them in the receiving facility's EMR. These professionals could be internal dedicated resources, but it actually may be more effective to use an external service. Now, with this combination of technologies and services, you will get all of the relevant historical information for a patient. Often, first visit cannot begin until all the records are in place for review. This very common practice often delays care and treatment for weeks. If the provider knew that all the records would be delivered in a few days, then timely appointments could be made and care and treatment could begin quickly. This is referred to as assured delivery. Now I'd like to bring together the solutions for images with the solutions for records. The cloud-based referral management application is added and fully integrated with the platform for sharing images. An external service of skilled professionals is used to manage the overall record retrieval process, and that includes collecting non-electronic records like pathology slides. The referral management application is used to store and manage all of the records in an organized manner and to transfer the records to the health system's EMR. Most importantly, the referral management application and these external services are used to assure delivery of the records in 3 days instead of 3 weeks, so patient visits can be scheduled promptly and treatment can begin without delay. This unified solution of a single technology platform combined with a service of skilled professionals can leverage your existing solutions, your EMRs, PACS, the HIE. It can adapt as these existing solutions progress to provide more comprehensive solutions for image and record sharing. It can fill in the gaps to share all image and records with all providers. Use a single platform instead of multiple solutions to get records electronically. And assure delivery to speed patient care and treatment. Now it's time to wrap up with some conclusions. We've seen that the healthcare system is broken when it comes to transitions of care. Significant issues exist with current approaches to sharing images and records. Key records are often missing, and accessing images is problematic. What is needed is a single unified technology platform that can fill in the gaps for both images and records. This solution would support getting images and records before treatment, support internal sharing during the treatment, and external sharing after the treatment. We've seen that HIEs have their limitations. Lots of key records never find their way to the HIE, and very few HIEs can facilitate medical image exchange. We've also seen that EMRs have their limitations. Key records don't find their way to the EMR, and EMRs, they don't manage image data or include an image viewer. Years of experience suggest that transferring image and record data as CD copies is also not the answer. And most of the current generation of cloud-based electronic image sharing services, well, they have their limitations as well. The goal is straightforward. What is needed is a unified approach to managing the internal and external sharing of images and records, and the importing of both records and relevant prior images. In technical terms, here's what's needed. First of all, we need a methodology for image enabling the HIE and the EMR, and that includes the technology for accessing the image data and a universal viewing application for displaying that data. Second, the technology solution must facilitate the exchange of data between disparate PACS. Third, the technology needs to support a methodology that will assure timely delivery of both records and images. And most importantly, the technology should be based on a single platform rather than multiple solutions. I believe that a unified solution, a single technology platform exists today. The technology components include an image exchange server, a DICOM router, a server-side rendering universal display application featuring zero client, a cloud-based referral management application, and a professional services component that can efficiently and effectively manage record retrieval. The entire package can be deployed, or any of the individual modules, depending on specific needs and budget. Now, a white paper that goes into this subject in more detail will be available shortly through eHeathTechnology's website. Thank you for attending the webinar. I trust the presentation has given you a few things to think about. Now, before we begin the Q&A session, I'd like to ask the audience to take part in the exit survey that will be popping up on your screen in a second. I also want to remind the audience that they can submit questions by typing them into the questions box and clicking Submit.
All right. Well, thank you very much, Michael, for that fantastic presentation. And now we'll go ahead and jump directly into the Q&A session. And our first question here looks like it's going to be for Ken. Ken, we have somebody who's made a comment in here. It says, I gather protection of PHI is indigenous to these solution applications. Could you comment on that?
Absolutely. Thank you. The answer to the question is yes. So certainly from the standpoint of managing PHI, we have to ensure that security is managed throughout the system. And the key aspect of a solution like this is to leverage existing authentication and also HIE patient consent controls and the like to enable access to this information. So don't duplicate that whole infrastructure. Once again, leverage the authentication and consent infrastructure that already exists, and that's another key part of the solution.
Okay, great, thank you. Our next question is going to be from Michael. Michael, wouldn't performance suffer if the EMR user had to wait for the universal viewer to query or retrieve the requested images from the PACS?
Interesting question. Yes, it would. That especially if the viewer had to query and retrieve each of these PACS systems on the fly. That is why it was recommended that the universal viewer have its own cache, and you would size the cache to hold 3 to 6 months of all that image data, which are certainly going to be the most likely images that people are going to ask for. So if the most 3 to 6 months of the images studies are already on this viewer cache, then the retrieval time of the viewer from that cache is going to be just about as fast, in some cases even faster than going straight to the PACS from the EMR. Now, it raises an issue. Some PACS, in fact, can't forward images to an external device until after they're interpreted. So if the PACS can't auto-route new studies to the cache or can't send them until after they're read, then the workaround, if you will, is to have the imaging modality set up to route new studies directly to the DICOM router that's built into this application, and then that router in turn routes the new studies to both the viewer cache and the PACS. So there are workarounds, but the point is you get the images into this viewing cache from the PACS or from the modalities, whichever, and once they're residing there, then the viewing application can very, very quickly respond to the user queries for those PACS, for those images.
And Michael, another question for you, more of a clarifying question. Someone's asking, what do you mean by VNA tag marking?
I love it when this question comes out. We've been talking about it for, 3-4 years now, and it continues to confuse. The front end of every DICOM image is the DICOM header, and the DICOM header, 128 bytes or so. Let me explain it this way. If you ever remember seeing how mail is sorted in a post office, you see that they put all the mail into the individual wooden boxes or metal boxes, each of which is an address. Well, the front end of the image is this header that contains all of these pieces of information, obvious things like the patient's name, the medical record number, the accession number, etc. A lot of these little boxes, if you will, contain information that describes what the image is. This is a CT image. There's all sorts of parameters of how you would view it. Here's another interesting example, and it ties to what we mean by tag mapping. So one of these boxes says it's the study descriptor. Okay, so one particular PACS system might decide to change what was sent from the CT and describes the study as CT head. And in that PACS system, CT head is very specific, and it fits into a hanging protocol, puts CT heads, hang them this way. Now what if the PACS system that describes it as CT head sends those images to another PACS system whose nomenclature is head CT? Okay, if you don't change that tag from head CT, or don't make another copy of it and change it to CT head, then the second PACS is not going to know how to hang that. Now that's an obvious example, There are many other subtle examples of tags that have to be changed, or the image doesn't really look right. Early on, I'll stop in a sec, but early on, you would hear people just complain that their images from their CR systems look fabulous on their CR control, but they don't look very good in their PAC system. And of course, the PAC system was from a different vendor than the guy that built the DR. So there's an example of a particular sort of lookup table scenario where if you don't know how to make that change, the images don't look good. They show up, you can view them, might even be able to hang them, but they don't really look right. So we need to make these tag morphs in order to assure that the images are not only completely compatible with, but they look right in the second system. So that's what we mean by tag mapping.
Okay, great, excellent. And then Ken, a question for you. Can a universal viewer be integrated into an existing EMR solution, and do EMR vendors adhere to this integration?
That's a terrific question. Thank you. From the standpoint of integrating into an EMR, the key is to provide a integration capability that's very straightforward. And the way this can be done is generally two mechanisms. The most common mechanism is through a single sign-on integration. And essentially, if an EMR can resolve URL links, then this solution is absolutely doable and straightforward from a standpoint of integrating into an EMR. There are other EMRs that also have some other workflow mechanisms already enabled around access to imaging for radiology results, as an example, or other APIs in order to make that integration possible. So there's a number of different ways, but they're very straightforward mechanisms to make that integration happen. Overall, the whole idea is to be very flexible from the standpoint of taking any of these capabilities and enabling the EMR with this referral management and image management. And so, again, leveraging the infrastructure that's there is key to how we manage a unified solution that really can cross boundaries and share information across multiple parties.
And Ken, do you have any examples of this, how this solution has been integrated with an HIE, and if so, how has that worked?
And we have a number of HIEs that have integrated the capabilities, and with some very good results. From the standpoint of, for example, image sharing and enabling that across regions and states, there's actually new information that's coming to light, documented evidence of reduced repeat exams based upon the access to images across a community, and knowing that these prior studies are accessible with essentially one click. So yes, there's real-world experience, integration experience in multiple platforms in order to enable this type of sharing.
And Ken, I'll ask you one more question before asking another one for Michael. Can you view PACS images without having your own PACS?
Another great question. Absolutely, yes. So that's part of the key. When you essentially image enable these platforms to be able to share this information and to have the zero client viewing capability, you're going to be able to view diagnostic quality images, full resolution images, process them with a suite of clinical tools without having to have your own PACS in place to do so.
Okay, excellent. And Michael, a question for you. Don't most of the cloud-based image sharing services allow you to forward images to other PACS?
It was at least a year and a half ago where I did a survey of who thought they were doing image sharing applications, and there were about 18 different vendor solutions that did that through the cloud. Well over half of them really, it was very interesting, they really didn't allow you to push the images into a local PACS, which was in a way kind of clever because they avoided the problem. If they didn't know how to tag map, then they wouldn't have been able to, in fact, make that very effective. So basically what happens is you push the images up into the cloud, and then you use their viewing application in the cloud to then view those images. That was the only option. So there was an external image share application that basically said, well, we're going to enable you to view them. Those services that actually did allow you to move images from the cloud then into the local PACS, a good percentage of those actually gave the PACS administrator a little set of tools that would allow them to manually intervene and modify a handful of tags. And some of the very obvious ones that would allow would change the patient's name if you had to, but most specifically change the medical record number from that of the sender to the receiver. So they allowed you to modify some of the tags manually, and in some cases including study description. But they didn't, in those cases, generally allow you to modify a lot of the other tags that more subtly were required to ensure that the image displayed properly. And I think part of that was due to the fact that you really had to know what you were doing to modify those tags. So they gave you the obvious, easy tags to modify, but not the tricky ones. So actually very few, I think a total of 2, and I'm not going to mention whom, but I think only 2 of these image share solutions actually did the same sort of thing we've been describing in this presentation, where they actually automatically, using a library of how you convert this to that, automatically manipulated the tags to guarantee compatibility and complete proper visualization in the receiving pack. So that's not many that figured out that we needed to do that.
Okay, excellent. Ken, a question for you. Can you still use this with an in-house referral coordinator?
Absolutely, and another good question. I mean, I think the key is enabling them with the streamlined workflow to make their jobs a whole lot easier. So if you're giving them access to tools that they don't have today to manage this process with the concept of assured delivery, which is ensuring that all of the relevant historical medical information and images that are needed for a patient are collected and delivered to where that patient is receiving care. I mean, that's ultimately key, right? The key is making sure all of that relevant information, regardless of how it originated, whether it was in digital format or we need to, to get it from another means, that's all aggregated together and delivered to the point of care for that patient. And so their job is greatly enhanced from the standpoint of employing this type of solution.
Excellent, great. And Michael, we'll get another question in here for you. It seems like a vendor-neutral archive is solving the same issues with images. Why not just buy a VNA?
Well, VNAs basically are designed to solve, well, among other things, consolidate storage. But they're designed to facilitate PACS-to-PACS compatibility issues. But the software, generally speaking, the application suite doesn't really support the process of sharing images with outside physicians or physicians outside the organization. And even the universal viewers, the standalone viewer applications, they don't manage credentialing for outside physicians. So that package, VNA plus universal viewer, that's at most an internal image sharing solution. It really doesn't address external sharing. And I guess maybe more importantly, or as importantly, as I said in the presentation, VNA is a big deal. I mean, it's a very big investment. So the image sharing platforms that we described in the presentation are hugely less expensive and a lot easier to deploy than a full-blown VNA universal viewer application.
Okay, excellent, great. Thank you very much, Michael. And it does look like we're nearing the top of the hour, so I'll just ask each of you. Ken, do you have any final comments you'd like to close out with?
Thank you. Yes, I mean, I think in general, the concept is to have a unified approach to dealing with not just imaging and images in a streamlined manner, but ensuring you gain access to all of that relevant historical information. And I think that's an area where people need to look at it and look at it from a broad point of view as to how we streamline these transitions of care in the best way for the patient. And I think that's really ultimately the key focus here, improving patient care through that process.
Absolutely. And Michael, any closing comments?
Nothing techy, but I would want to mention that I am going to be attending the upcoming HIMSS meeting in New Orleans, And I'm participating in eHealth Technologies Meet the Experts reception on, I believe it's Monday evening of the meeting week. All of you online, all of you that have been attending are going to receive an email invite shortly. Please RSVP for that. And I look forward to speaking with you individually there at the meeting. So that's it for me.
Excellent, Michael. Well, we look forward to seeing you there. And thank you, Michael and Ken, for that fantastic presentation. And thank you, everyone, for joining us today. If you'd like to view the archive of this webinar or share it with a colleague, please visit the on-demand section on HIMSS.org or governmenthealthit.com. Thanks again, and have a nice day.